Hi, welcome to another video. In this video, we are going to discuss the past paper of ASN level, paper 2. Paper 1 of 2020-22 February March already being uploaded. If you have not seen the video, you can see, go and check the videos uploaded. So from this paper, we are going to discuss the major portion of your syllabus, which is organic chemistry. So chapter wise we are discussing. So now we are discussing organic chemistry. So we will do all the problems of organic chemistry. Let's see what are the problems here. The organic chemistry. Okay, here's a problem. This question says HBr reacts with propene to form two bromoalkanes. Okay, complete the diagram to show the mechanism of HBr and propene to form the major product. Okay, so includes charges, dipoles, ion pairs, electrons, and curly arrows as appropriate. Okay, so here your double bond is having the electron source. The majority of the electrons is over here. Now here hydrogen bromide, it has a dipole, bromine being electronegative, so it is delta minus and this is delta plus. So this double bond is going to attack to the hydrogen and this HBr bond is going to break. This is the step 1. So in this step, so carbon, then this carbon will get a positive charge and this carbon will get the hydrogen. Okay, so this is your one carbocation which is of 2 degree, and another possibility of carbocation which could form, where there is first position there will be a positive charge, but as the question is asking for the major organic product, so this will be your major organic product because this is a 2 degree carbocation which is more stable than that of 1 degree. Okay, now in the next step, as it is from Br minus, so now this Br minus is going to attack to this carbocation. Now your product, the major product is ready. So this is your major product. Yes. So these are the 2-3 steps which you need to follow. Right. Let's move for the next. Explain why the two bromoalkanes are not produced equal amount by this reaction. Because you need to write 2 degree carbocation is more stable than 1 degree. So, sorry, 1 degree. So because of that, the more stable carbocation will form in a major amount. Right. Let's move for the next. The reaction of CH3CH2 CH2Br and NaOH in different, depending on whether the water or ethanol is used as a solvent. Okay, this question was also asked in paper 1. So those who have seen the video, you may found that the same question was asked in a different way. So let me just remind you what is the reaction. The reaction of Rx is in presence of sodium hydroxide, but the solvent is going to matter over here if you are using water. So this X is going to replace by OH minus by nucleophile. ASN reaction is going to happen, substitution nucleophilic reaction. So ROH is going to form, and along with that NaX. But the same reaction if you are doing with sodium hydroxide but ethanol solvent, so this reagent is removing HX. Okay, a beta elimination is going to happen. So HX is going to eliminate, then there will be a double bond is going to form, CH double bond CH2. Okay, So sodium hydroxide and ethanol is going to form a double bonded compound, along with that HX. Okay, so let's see the question. The question says the organic product. You have propane, and bromopropane. So in presence of sodium hydroxide and water, it's going to form CH3, CH2, CH2, OH. So propanol. Okay, and your inorganic product will be sodium bromide, NaBr. Great. Now, in presence of ethanol, there will be a double bond instead of OH, CH3, CH, double bond CH2. Okay, so propene, and then the inorganic product is HBr and water. Okay, so HBr is your inorganic product. So this is the answer for this question. Let's move for the next. Next question is the compound J and K found in plant oil. Okay. Complete 4.1, observe J the reagent. Okay. 2,4-DNP, toluene and sodium metal. Okay, let me tell you about this three reagent. 2,4-DNP. The similar question was there in paper 1 also of this year. I have explained this one. So 2,4-DNP is a reagent which is going to identify C double bond O, which is a ketone, or else an aldehyde. Only these two groups are identified by 2,4-DNP test. What about toluene reagent? Toluene reagent is to identify CHO group. Okay, it reacts with Ag plus ammonical silver nitrate solution is the toluene reagent. It's going to oxidize this CHO to become COO minus, and then itself going to reduce to form silver. So a silver mirror is being precipitated. Silver is being precipitated. So this is called the toluene reagent. In this reaction, only aldehyde is going to react, but no ketone. Okay, ketone cannot be, tested with this toluene reagent. Next is sodium metal. Sodium metal do not react with aldehyde, do not react with ketone. It does react with COOH group or else OH group. So it's going to displace the hydrogen of either COOH or OH by sodium. So let's now conclude about the answers. Observation with J, 2,4-DNP. So there will be red PPT or orange PPT. Orange PPT you'll observe an orange PPT. Why? Because there is a ketone group I can observe. So this ketone group is going to give 2,4-DNP test. Okay. What about toluene reagent? Toluene reagent also be positive because this CHO group. So toluene reagent is positive, and gray color silver precipitate you will observe, silver mirror precipitate. Okay. The next one, sodium metal. So sodium metal also going to react because there is OH. So hydrogen gas, effervescence of hydrogen gas is going to produce because sodium is going to displace the hydrogen of OH group. Okay. Now this is about the answers, all three answers. Next is J has two optical isomer. Yes, definitely, because J is having a chiral center. So if there's a chiral center, then we need to draw the mirror image of that, which is going to give us the two optical isomers. So let's draw it. So you need to put a bold bond. The bold bond is for above the plane, and the dotted bond which is the below the plane. Now you can put anywhere any groups, not an issue, but considering this one as a mirror, so you have to draw exactly the same of mirror image. Let's just imagine that just in front of you, there's a mirror. So how does it will look like? So it will look like this. I'm trying to make it as much as same image it can form. So CH3 and the dotted one CHO, right? So these two will be the mirror image, the optical isomers of J. If this isomer is a plus isomer, this will be your minus isomer. Okay, let's move for the next. So a lot of questions are being asked from organic chemistry. Do prepare well for this topic, and the questions are always easy. Okay, now K is used to make the additional polymer prospex. A synthesis of this substance is shown 4.2. Okay, so reactant L and reaction 1. Okay, so what is the reaction happened over here? I can see COOH group is converted to COOCH3. Okay, so RCOOH is being converted to RCOOCH3. So this is an ester, and this is carboxylic acid. So how carboxylic acid is being converted to ester? It's going to react with an alcohol. So alcohol will be CH3OH and in presence of H plus catalyst, okay, or H2SO4. May write concentrated H2SO4. So let's write the reaction. L is the reactant, which is our CH3OH methanol, and condition is concentrated H2SO4. Okay, draw one repeating unit of the addition polymer of prospex. Okay, so K is used to make the addition polymer of prospex. So K, we have to take K. So what you need to do, you need to join the double bonded carbon. Okay, so let's say this is one unit. I'll show you with a different color pen, so that will be easy for you to understand. Let's take another unit. Okay, so I just remove the double bond and join the two, and the rest of the hands whatsoever XYZ whatsoever is there, you just put as it is in their position. Okay, so then your polymer will be done. Okay, look, I made one unit, and for the second unit, this is the carbon which is containing CH2, this carbon. I'm putting a star so that you can identify. So here will be H and H, and then here it will be COOH and CH3, right? So two unit we joined, and it's going to form the polymer. Okay, let's move for our next question. Next question is saying K can be made from propanol. Okay, in the following steps of the synthesis. Okay, the step one. Okay, step one is an addition of HCN. We can see if there is a double bond ketone or aldehyde whatsoever, nucleophilic addition reaction is possible. So HCN, so Cn is delta minus, is delta plus, here is delta plus and delta minus. So plus, you just add plus minus oppositely. So what is going to happen? C, with the C there will be Cn, and with the O there will be OH, right? So here in the first step, the reagent is HCN. We can see. You may write KCN also. Then you have to write H plus. If you're writing KCN, then you have to write H plus. Okay. Then what is the type of reaction? It's a nucleophilic addition reaction, right? Addition reaction. Addition to carbonyl carbon. Okay, step number 2, I can see Cn is being converted to COOH. So how Cn can be converted to COOH? If you do the hydrolysis of Cn. Okay, so hydrolysis of Cn, what will be the reagent? H plus and H2O. Okay, if you do the hydrolysis, Cn will become COOH. Okay, and rest will remain same. This is the reaction only going to happen to the Cn group. So your reagent is H plus and H2O, and it's a hydrolysis reaction. hydrolysis reaction. Next step, the reagent is given Al2O3. Al2O3 is a hygroscopic compound. It absorbs water. It helps to eliminate water. Okay, so I can see this OH group and hydrogen from this carbon, the carbon I made star. So H and OH is going to eliminate to form this double bond. So it's a type of elimination reaction. Let me show you the reaction. So CH3 is there, and then COH, CH3, and then COOH. Now this H and OH is going to eliminate in presence of any dehydrating agent like Al2O3 or concentrated H2 support could be also used over here. So this presence of this two is going to form you a double bond over here, right? And the rest of the bonds are not going. Yes, so elimination reaction is a type of the reaction. Okay, let's see. Yeah, there's no more questions from this paper too. So I think 20 to 30 marks you're going to get, more than 30 marks you're going to get from organic chemistry. So prepare well. Thank you so much. If you like my videos, please subscribe my channel, and if you need tuitions, one-to-one personal classes, please follow the screen after this video. Thank you.